Okay, so the next section, just put the phones away. Okay. The next section is actually, it's two small lessons into one. So it's two smaller lessons into that, that I moved into one because each of them on their own is pretty small. The first one is what we call solving differential equations. Okay. And then the second one, slope fields. So solving differential equations. Well, what in the world is a differential equation? Well, you guys have been seeing them since September. Differential equations are just derivatives. That's all they are. So anytime you find a derivative, that's a differential equation, right? F prime of x equals dy dx equals something. That just means it's a derivative. The equation is a derivative of something. That's all it means. That's all this stuff says. Okay? So you guys have been seeing this for a while. Okay? But sometimes we don't call them differential equations. We call them something different. That's a first derivative. This is a second derivative. That's a first derivative. Okay? All right, so what we're doing today is solving those guys. So how do we solve them? We're going to be using integration. Because how do you... So when you take an integral of a derivative, you get back to the original. That's what we're doing today. We're just getting back to the original. All we're doing today, all of this stuff says is we're using antiderivatives to get back to the original equation. Okay? So these are the steps. So we're going to use something called separate or separable differential equations. Okay? So when we see things, they're going to have a dy dx. Everything with a y, we're going to move to the left side of the equation. Everything with the x, we're going to move to the right side of the equation. That's our first step. Once we do that, we're going to integrate, antiderivative. We need to add a plus c side to 1, and then solve for y. Solve for y. Okay? So the process isn't very hard. It just takes practice. Okay? All right, so solve this equation. So this is the equation we got to solve. It's a differentiable equation, meaning that's the derivative of something. I don't know what, but it's the derivative of something. Okay? Not only do they want me to do that, but they also want me to use this. When x equals 0, y should be 2. Okay? So first step. Move everything with a y to the left side of the equation. Move everything with an x to the right side of an equation. Okay? So I have two sides of an equation. Everything with an x needs to go to the right. Everything with a y needs to go to the left. So we got to go through. Let's go through this piece by piece. This guy's got a y. What side was the y going to be on? Left side. Is that on the left side or is it on the right side? So we leave it there, right? Underneath it, you have a dx. What side was the x is going to go on? So this guy needs to go over here. And then over here, I just have sine of x, right? That's already on the right side. We're good there. So pretty much the only thing I need to do is figure out how to move this guy over here. Okay? Mathematically, how do I do that correctly? I have 4 options. Add, subtract, multiply, or divide. Those are the 4 things I can do to move it. So which one of those things would be the correct way? Multiply, right? Because it's being divided, right? Divided by dx. So we're going to multiply both sides by dx. That gets rid of that. So we get dy equals sine of x dx. Okay, first step is done. Everything with a y is to the left side of the blue line. Everything with an x is to the right side. That's the first step. The second step, integrate both sides. Antiderivative now. integrate both sides, all right? So I need to integrate both sides. So what is the antiderivative of this guy here? This is a little, not a little tricky, but it could be a little confusing at first. Yes, why would it be just y? Because a lot of people see that dy and they like, I don't know what that means. You're right. Why would this side, the antiderivative of this side, just be y? You're right, yeah. The dy, that just disappears, right? The dy dx, this part disappears when we take antiderivative, right? So we don't got to worry about that. Well, this guy is really the one we're finding antiderivative of, right? So what is this part for this guy here? There's nothing there, right? But there's always something. So in its place, what should be there? A 1. What's the antiderivative of 1? It would be y to the first power divided by 1, which is just y. Okay? So that's why the antiderivative of this side is just y. The other side's a little more where we're used to seeing. What's the antiderivative of sine? Cosine. Yeah, because the derivative of cosine is sine. Wait, is that right? Or is it negative sine? It's either negative or positive. I can't remember. I can never. I want to make sure we do this right. Let's see. Sine, yeah. Regular, or no, wait. Sorry, I looked at the wrong one. It's negative cosine. So the antiderivative of sine is negative cosine. So we put negative cosine of x, and then we have to put a plus c since we have no bounds. Remember, if we have no bounds, we always put a plus c when we find the antiderivative. Okay? The next step, sometimes that's the second step. Find the antiderivative of both sides. The third step, sometimes this is done already for you. The third step says solve it for y. Make it say y equals. Well, it already says y equals, right? So they did that step for us. The last step is, now I got to include this guy. So that means when I plug in 0 for x, y should be equal to 2. So I got to plug in those values now. So 2 equals negative cosine of 0 plus c. Okay. Well, cosine of 0 is positive 1. With that negative in front, it's going to be negative 1. Solve for c. C is equal to 3. So let's put c back in. And our finished answer, done. So they're going to ask you for 2 separate things. First thing they're going to ask you for, because I'm going to highlight these and show you how they're different. This is what we call a general solution. It is the answer, but it's the general solution. General meaning it could work for a lot of different things. So we call this the general solution. This guy over here is the specific, or what do they use? They use specific, I can't remember what other words, specific solution. So they're both solutions. Sometimes they just want the general solution plus c. This general solution always has a plus c. The specific solution never has a plus c. Why is it specific? Because it's specific to this problem. When I plug in 0, I get 2. The general solution works for any points. Any points. So it just depends on what answer they want. Okay? If you're not sure, give them both. Okay? All right, so let's try another one. Sorry, particular. Sometimes they call it particular solution too. Specific, particular, kind of the same thing. Let me put particular solution. Sometimes they call it a particular solution. It's more specific. Okay, so example number 2. They want both. They want the general and the particular. Okay. Okay, so this is the guy that we need to solve with. F of x equals 3x squared dx. Okay, first step. Y is to the left, x is to the right. I don't see any y's. F of x is y, yeah. F of x is y. So this one, they kind of started ahead of us because they're already doing antiderivative of one side. Well, we got to do antiderivative of the other side too. What's the antiderivative of y? So it has a 1/2 y squared. What's the antiderivative of 3x squared? 3x to the third divided by 3 plus c. What's that?
Just x to the third.
So yeah, so when we clean it up a little bit, you're going to have 1/2 y squared equals x cubed plus c. This time, they weren't so nice. They didn't solve it for us yet. Okay? So this is what we're going to do. So I'm going to solve for c first. I'm going to solve for c first. You could do it in any way. I could solve for y first, or I could solve for c first. Doesn't matter which way you do it. I like to plug in before I solve for y, but that's just me. You could solve for y first and then do that. So I'm going to solve for c. So anywhere I see an x, I'm going to plug in a 2. Everywhere I see a y, I'm going to plug in a -3. -3 squared is 9, times 1/2 is 9/2. 8 plus c. Subtract 8 from both sides. Eight is going to be 16/2. So I get -7/2 equals c. Okay, so I'm going to plug that in. I'm going to kind of go over here now. I'm going to rewrite this. Except now I have my c, -7/2. Solve for y. Okay, well, the first thing I got to do is I got to multiply both sides by 2 to get rid of the 1/2. So I get y squared equals, I distribute, and you're going to get 2x to the third minus 7. Because 2 times 7 is 14, divided by 2 is 7. Last thing, square root. So anytime we solve, we're solving for y. So if you're solving and you take a square root, you got to have two answers. So we're going to have a negative and a positive. A negative and a positive. Done. Okay. So it's pretty much the same steps every time. Move y's to the left, x's to the right. Check. Antiderivative. If there's points to plug them in. If there's not points to plug in, leave it alone. So the general solution would be plus c. Yeah, so it would just be a plus c. Yeah, so it wouldn't have a 7, right? So yeah, so the general solution, we'd move over here. So you'd get 1/2 y squared equals x cubed plus c, right? We would do the same thing. You multiply both sides by 2. Here's the thing, though. You don't multiply c by 2 because c is just a constant. So it's just c. And then you take this guy here. So you would get y equals plus or minus 2x cubed plus c. So very similar. Very similar to the general solution, particular solution. Okay. Okay. That's essentially every problem we see for this is the same thing. That's why it seems like a lot, but it really isn't. You're just doing the same thing over and over again. Sometimes what they'll do is they'll change the wording. So now we have acceleration, velocity, and position. We've seen that many, many times before. What's the relationship between position, velocity, and acceleration? They're all related somehow. So how are position, let me highlight them. Position's the original, good. Position's at the top, the original. Its derivative of its velocity. So first derivative of position is velocity. And then acceleration is the second. So yeah, it's kind of, so position, velocity, acceleration. So if you want to go down the list, you take derivatives. The first derivative of position is velocity. The first derivative of velocity is acceleration. The second derivative of position is acceleration, etc. If you want to go up the list, you do antiderivative. So if I have acceleration and I want to find velocity, I got to find antiderivative. And if I want to find velocity or position based on velocity, I got to find antiderivative. So up the list, antiderivative. Down the list, derivatives. Just depending on which way you got to go. Okay? Okay, so the acceleration of a body moving along a coordinate line can be modeled by the function a of t equals cosine of t. They want us to find the velocity and the position when velocity equals this and position equals this. So we got to start at the bottom. We're starting with the acceleration, and I got to work my way up. I can't make a jump in one. I have to go one by one. So first thing I have to do is up to velocity. That's going to take antiderivative. Okay. So what I got to do is I got to find the antiderivative of acceleration. The antiderivative of acceleration is velocity. The antiderivative of cosine, we just talked about this, is a negative sign, right? Plus c. That's the general solution for velocity. But they want a specific solution right here. When I plug in 0 to v, velocity, I get -1. Okay, so I got to plug in 0 for t. And I'm going to plug in, everywhere I see a t, I'm going to plug in 0. Everywhere I see a v of t or a y, I'm going to plug in -1. So -1 equals negative sine of 0. Wait. No, sorry, I did this wrong. It's supposed to be positive sine. The antiderivative of cosine is positive sine. I thought it was the same as the last one we did, but it was different. So this is going to be positive sine, yeah. The other one was the antiderivative of sine was negative cosine. I got those mixed up. Okay, so the sine of 0 is 0. C equals -1. So v of t equals sine of t minus 1. That's the velocity function. That's one of my answers. Now I have to use that to find the position. Okay. All right. The antiderivative of velocity is position, s of t. The antiderivative of sine is negative cosine. The antiderivative of -1 is negative t plus c. Okay. That's the general solution for position. That's the general solution for position. But they want me to plug in 0 now for t. Should equal 1. Okay. Cosine of 0 is 1, so this is going to be -1, minus 0 plus c. -1 plus c. Add 1 to both sides. 2. C equals 2. So, there's the position. The specific or particular solutions. Particular solutions. Particular solutions. One is for velocity. One is for position. So that one we had to climb up two steps of the ladder. All right, let's do this one now. What is the particular solution to the differential equation? So we have a derivative equation here. With the initial condition that when I plug in 3, I get -4 as an answer. So this is our first real one where we have x's and y's mixed up. Before, we haven't really had to have that problem. I think we multiplied the first one by y, dy, but that was it. This one we're going to, or dx, this one we're going to have to do some lifting. Everything with a y needs to come to the left. So let's take a look at this. This guy is already on the left. This guy needs to come left. Everything with an x needs to move over. That needs to move over. Okay. So dx, to move dx, I'm going to multiply dx by both sides. X squared plus 3 divided by 3y times dx. How do I get the y? So now I got to move this guy over here. I have 4 options again. Addition, subtraction, multiplication, division. What is it going to take to move that guy over there? Multiplication, right? Because it's division. So now I'm going to do multiplication. (3y dy). X squared plus 3 dx. So now let's look. 3y dy, good. X squared plus 3 dx. So the only thing that doesn't have an x or an y is the 3. That's a constant. Leave it to the right. Leave it with the x's. So if it's a constant, just leave it with the x's. Okay. Next step. Antiderivative. We just did a whole chapter where we were doing antiderivatives. This is why. So the antiderivative for 3y. The antiderivative for 3y is going to be 3y squared divided by 2. We're not going to put a plus c here. I'm going to put it on the other side. We only need one plus c. I'm going to put it on the other side. The other one, the antiderivative of x squared is x to the third, 1/3 x cubed plus 3x plus c. Okay. So we have 2 options here. Solve for y and then plug in the values, or we can plug in the values first. I personally, just from past experience, I've been doing this a while, I find it's easier to plug in the numbers now and solve for c. That's just my preference. Do you have to do that? No, you could solve for y now and then plug in the numbers last. It's up to you. It's just a matter of preference. So I'm going to plug in 3 for x, -4 for y. 3 for x, -4 for y. Okay. Everywhere I saw y, I plugged in -4. Everywhere I saw an x, I plugged in 3. Okay, let's solve for c now. So we get 3 over 2 times 16. 27 plus 9 plus c. So 3 over 2, let's see. So it's 16 over 1. So I can simplify that to 8, 1, 24. And then 27 times a third is really, you're dividing it by 3. So it's 9 plus c. C equals 6. Sometimes you'll get a fraction for c. It's not wrong. It's not necessarily wrong. Sometimes you won't. This time we did. So now I'm going to go over here. Plus 6. Last step, solve for y. So first thing I got to do is I'm going to multiply by the reciprocal. Got to multiply everything by the reciprocal. So let's see. So when I do this, I'm going to distribute. 2/3 times 1/3 is 2/9. X cubed. Two-thirds times 3x is 2x. 2/3 times 6 is 4. Square root. Okay. Okay. It's the same steps. Like I said, it's the same steps. This isn't terribly hard, especially the only part of this where calculus is done is this part right here. And literally, it's probably the easiest step because doing antiderivatives of these guys, you don't have to use U substitution. It's not very hard. Okay. It can be tedious, which is one of the reasons why these types of problems are FRQs a lot. You'll see these for FRQs quite a bit. They're not necessarily multiple choice questions. They're FRQ questions. Because multiple choice questions, they try to keep shortish. These types of problems, they'll take you a little bit of time. That's why they move them to FRQ. Okay. All right. Okay, start number 5. I want you to practice, do number 5. Get as far as you can, and if we don't finish, we'll do the rest. We'll finish number 5 tomorrow. But at least want you to get as far as you can on number 5. Move all the y's to the left, x's to the right. Start there. I have a question, though. Who's that negative belong to? X or negative 2y squared? Doesn't matter. Doesn't matter. Whichever you choose. Pick one, give it to them. Pick one and give it to them. Just don't give it to both.